In this video, we will show the options that we have and the steps that we must follow to export a RAM structural system model into ADINA. The first step is to navigate to File, Export ADINA Options, and the ADINA Export Options dialog box will show up. This dialog contains 4 tabs: General, Static Linear, Eigenvalue Analysis, and Time History Analysis. Under the General tab, we have options to specify what results we want to output when the analysis is run in ADINA. For instance, we can specify if we want to store the minimum results or to save maximum results. Note that the results file may become substantially large for time history analysis if Save Maximum Results is selected. We can also choose what results we want to output for shells and beam elements. For shell elements, we can choose between saving nodal forces and moments or stresses and strains. For beam elements, we can choose between saving nodal forces and moments, stresses and strains, or section forces. The new option ResultsDB SQLite allows to export results in database format. The following 3 tabs allow us to specify what ADINA input files we want to generate out of this RAM structural system model. Let's have a quick look at each of them. Under the Static Linear tab, we have options to generate ADINA input files corresponding to linear static analysis with either gravity load cases or lateral load cases. In both cases, the general structure and the engineering properties that will be exported to ADINA will be the same. The difference between these 2 ADINA models will be the applied load set. The Eigenvalue Analysis tab includes an option to generate an ADINA input file for a frequency analysis. Here we have options to specify the number of frequencies and modes that we want to calculate, as well as the numerical method that will be used. Note that the ADINA input file for eigenvalues will only be created if the model includes an eigenvalue load case. Then finally, the Time History Analysis tab includes an option to generate an ADINA input file for time history analysis. This dialog allows to specify a time history analysis of ground motion type. We can of course specify other types of time history analysis after exporting the model from RAM into ADINA. Let's have a look at the options that we have under the Time History Analysis tab. Time parameters allow us to specify the time start, the time end, and the time increment or time step that will be used for the solution. There are 2 methods that we can choose between, which are mode superposition and direct time integration. Mode superposition assumes that the structure behaves linearly. Direct time integration can be used for linear or nonlinear time history analysis. Within direct time integration, we can choose between the traditional numeric methods or the special Bassett technique, which is specific to ADINA. The automatic time stepping in ADINA is a useful feature that will reduce the time steps automatically if the analysis is not converging. It is possible to apply damping in the way of Rayleigh damping coefficients, mass proportional damping coefficient, and stiffness proportional damping coefficient. And finally, under load history, we have the options to introduce ground motions in the global X, Y, and Z directions. We can click on Open File to load the time history, we can apply a scale factor to it, and we can also show this time history in a graphical way. We can find more details about the ADINA export options by clicking on the Help button. After choosing all the options and selecting the ADINA input files that we want to generate, we can click on the OK button to close the dialog. Finally, To actually generate the ADINA input files, we must navigate to Process, Analyze, make sure that we have all relevant load cases selected, confirm that we have the Generate ADINA input file option selected, and click OK. The input files will be saved at the location indicated on the message that appears on the screen. We can open the generated input files from ADINA User Interface, Start button, Open Batch. We find the input file that we want to open. In this case, we will select the Eigenvalue Analysis input file. And in this case, we can see that the model has been imported with mesh, materials, cross-sections, supports, constraints, and concentrated masses. We can also see that the analysis type is defined as frequencies and modes, as we were expecting. And if we click on the Analysis Options button, we can also confirm that the number of requested frequencies and modes is 20, as we specified on the RAM to ADINA export dialog box. With this, we conclude this training video. On next videos, we will show interoperabilities between other vendor products in ADINA, as well as examples of complete workflows from the beginning to the end. Thank you very much for watching, and I will see you on next videos.